Okay, we're starting to look at inverses, and we did this last semester. We did it with lines and with radicals and with parabolas, and the idea was that inverses reflect over this line y equals x, and if they cross, it's going to be actually on that line. If they don't cross, it's going to be still a mirror image, and points are going to change position. So if you look at this graph right here, for instance, that's the graph of y, I see the point -2, -5. If I look over here at this graph, I see the point -5, -2. The x and y values flip-flop. Over here, I see two graphs. These are inverses of each other. I have a graph here that has an x-intercept of 4, 0, and over here I have a y-intercept at 0, 4. So again, the idea is that x and y's are changing position. In our unit here, we have to work on the algebra. So I'm going to show you where we're going with this. And we're going to start off with log graphs, and their inverse is going to be an exponential graph. So the thing that we have to remember is you literally switch positions. Where there's a y, you write an x, and where there's an x, you write a y. And then your goal is to solve for y. So the first thing I want to do is add 1 to the other side, and then I've moved that x value. And then I want to figure out if I have logs on one side, numbers on another, I use my definition. 2 is my base, so I'm rewriting using exponents. 2 raised to the x plus 1 equals y plus 5. So I'm almost done, but I still have to subtract 5 from both sides. So if there were like an answer blank, the way I write it for an inverse is using that notation with the little -1. So y inverse equals this right here. 2 to the x plus 1 is an exponent, so it's up high, minus 5. Let's do another. I'm rewriting an x and a y in opposite places. So x equals log base 2 of y minus 4. I have logs on one side, x on another, so I'm going to rewrite it using exponents. 2 is the base. 2 to the x equals y minus 4. Get y alone by adding 4. So again, if there were an answer blank, the way I'm going to answer it is y inverse equals this. 2 raised to the x plus 4. And then the last one, if you notice, it has f of x in it. You can think of that as being the y. So I'm going to rewrite x equals natural log of y plus 4. Need the log statement alone, so I'll subtract 4 to the other side. And now, remember, natural log really means log base e. So when I rewrite this using exponents, my base is e. E raised to the x minus 4 equals y. So on my answer blank, something a little bit different about this function notation. To say the inverse, you put the little symbol between the f and the parentheses. So f inverse is e to the x minus 4. So that's inverses. If you start with logs, expect to get exponents. Now if I go in the other direction, if I'm starting off with an exponent, and I'm going to do my rewrite step. I'm going to rewrite x where y is and y where x is. So my exponent is now y minus 5 plus 4. I need to get that base part alone, so I need to subtract the 4 over. I have x minus 4 equals 2 to the y minus 5. To solve for a variable in the exponent, I need to write it using logs. This is log base 2 of this whole thing. Very important that you keep that in parentheses. Equals y minus 5. So almost done, but I need to get y alone by adding 5 to the other side. So in my final statement, my inverse is going to be this left side. Log base 2, so 2 is the subscript, x minus 4 in parentheses, plus 5. Plus 5 is outside the parentheses. Another example. I'm going to do the same thing where I rewrite. I'm going to change my y to an x, and I'm going to change my x to a y. I'm going to subtract the 5 because I need to get this base part alone, and I'll have 3 to the y minus 8. Again, solving for a variable in the exponent, rewrite it using your log definition. This is log base 3 of the whole thing, x minus 5, you need parentheses, equals y minus 8, and to get y alone, we're going to add 8 to the other side. So now in my answer blank, my inverse is this left side. Log base 3 of the quantity x minus 5 plus 8. And lo and behold, we're going to have something with an e, so anticipate a natural log in our future. This part is like the original y. So when I do my rewrite, I'm going to have an x here equals e to the y minus 9. I need to get that base alone by adding the 9 over. So I'll have x minus 9 equals e to the y. Now you can write this however you'd like to. I'm just going to apply my definition just like I did up here. Log base e of the quantity x plus 9 equals y. So this is good. I got y alone. And what goes on the answer blank is that notation for the function f inverse of x equals, now, are you going to write that? No, you're going to simplify it. Natural log of x plus 9. So that's the direction to go into, and I just want to emphasize this right here. If you don't have parentheses, it is wrong, because to say log base 2 of x minus 4, it is different if you had log base 2 of x minus 4. Parentheses matter. Those two are not the same. So pay attention to a quantity. If you have to pull it over with parentheses. And like we started looking at graphs, I want to finish up with what the log and exponential inverse graphs look like. You do have to remember some things here, so you might have to go back and practice your graphing. We've just done logs, and we know our key points on logs are 1, 0, and base 1, and 1 over base negative 1. And if that seemed familiar, it's because when you learned exponents, you did the opposite. You did 0, 1, and you had 1 base, and then you had negative 1, 1 over base. So if you learned in Unit 11 your exponent graphs and remember them a little, that's what's moving. So if I'm looking at the f of x graph, and I started with 0, 1, 1 base, the base here is 3, these are the points that moved right 8 and up 5. So from these points, if I move right 8 and up 5, right 8 and up 5, it puts me here. When I move up for my f of x graph, I had an asymptote, and I can draw the graph. Do remember when you're doing two graphs to label which is which. Your log graph that we just did starts off at 1, 0, and 3, 1. So if I had 1, 0, and 3, 1, they're going to move right 5 and up 8. So if I move right 5 and up 8, right 5 and up 8, I get these points. And when you move to the right on the log graph, it moved your asymptote. So I had this graph for g of x. So what do you notice? You notice that when they cross, it is on that line y equals x. So that's a good thing. And so that means you are, in fact, looking at inverses. Remember something else. If they're inverses, the domains and ranges are going to change. If you focus on the f of x graph, its domain is everything. It goes left and right forever. And if you look at the g of x graph, its range is everything. So in fact, the domain from one became the range of the other. If I look at the range of the first graph, now remember range is wide value, and this value right here is at a 5, so it goes from 5 and up. And because there's an asymptote, we're going to use a soft bracket. Is that the same thing as the domain on g of x? Sure is, because this x value that it starts at is 5, and it goes to the right forever. So remember that domains and ranges switch position on inverses. And is it a function? That question is yes for both of them. You're using your vertical line test just to say that an exponential graph is a function and a log graph is a function also. Good luck with inverses.